All right, how are you today, everybody? Let's watch this video before we start today's class. It works fine. Yes.
This is the semi-arid land between the Sahara Desert and the humid savannas. The Sahel drylands are one of the world's poorest regions, characterized by low precipitation of only 100 to 300 millimeters a year. These areas have been plagued by droughts and food insecurity for centuries. In the dry season, insufficient rainfall results in water scarcity, low crop production, and a severe reduction in tree coverage. This in turn causes a loss of plants and animal species. A low biodiversity means crops are more susceptible to pest attacks. In the rainy season, intense bursts of precipitation can destroy and wash away soil, newly planted seed, and crops. This is called desertification. The land is degraded to an unusable state, and people are forced to migrate to more prosperous areas. Furthermore, the Sahel has one of the highest rates of birth in the world. The rapid population growth puts more strain on food production and leads to increasingly aggressive means of harvesting, contributing to loss of soil fertility. Around 80% of farmlands suffer from degradation. Local farmers, in cooperation with NGOs, have come up with 3 solutions. To restore degraded soils, farmers dig rows of pits called zai, piling the removed soil around the edges and filling it with organic matter. The edges divert water and wind-blown nutrients into the hole, while the organic matter attracts termites who dig deep channels that loosen the soil to better absorb nutrition and water. In early July, the seeds are planted, resulting in better crop yields and tree cover. To harvest rainwater and reduce soil erosion, farmers use stones to form contour bands. These rows of stones are precisely placed at the same elevation and act as a sieve, slowing down the flow of water and preventing minerals from being washed off the fields. Thirdly, farmers select trees especially useful to them for food production: wood, soil, fertilization, or fuel. The tallest and straightest stems are selected and protected, while unwanted stems and side branches are removed. This is done regularly to avoid new sprouts competing for resources with selected stems. These 3 methods have not only stopped the advancement of desertification, but they have successfully rehabilitated many thousands of hectares of soil and show a 40% increase in crop production already after the first year. This helps meet the demands of a rapid growing population, and in Niger, farmers could even export a surplus. More trees means more shade, higher biodiversity, a rise in water level, and less wind erosion. As a result, agriculture became a stable source of income, and people no longer needed to travel long distances for firewood and water. These hours can now be spent to engage in economic activities and family care. Due to their success, simplicity, and low cost, these methods have spread rapidly through the countries, passed from one farmer to the next, through open fairs and taught through schools.
Okay. I hope you are all there. Welcome everybody to today's class. I know we have not been meeting regularly, but try and see how we can make amends. So today we want to talk about another very interesting topic. We want to look at desertification and sand dune fixation. So desertification is a process that results the degradation of land, particularly in arid, semi-arid, and dry subhumid areas, usually caused by various factors. Factors such that are either based on natural processes like the influence of climate change, and sometimes anthropogenic activities like overgrazing, deforestation, overuse of water resources, salinization, mining, sand movement, etc. These are all some of the things that cause or accelerate, that either initiate or accelerate desertification. I hope you can hear me. Can you hear me?
Yes, sir.
All right. Excuse me.
Yes, sir.
Generally, land degradation leads to a decrease in soil fertility, water availability. I hope you all know what net primary production is by now. I think we discussed it in 200 level. Plant cover, loss of plant cover, and loss of biodiversity. And of course, it's believed that changing climate, particularly the threat of climate change, will further accelerate the desertification process being experienced around the globe today. And you know, from our class on natural ecosystems, you know that we have desert areas all over the world, whether it's in Africa, on all the continents, we have some parts of the land that are desert areas because of the amount of precipitation, and the amount of the relative humidity, those climatic factors, because of their variability. So you have desert areas all over the world. And the remobilization of sand dunes are those aggregated sands that result from particularly wind erosion, can cause, pose a threat to villages, to buildings, to roads, to infrastructure. And this here sort of shows you the vulnerability of different parts of the world. And you can see the red indicates that there is high vulnerability of such areas to desertification or desert encroachment. And you can see that many of these areas are the extreme edges of the dry regions of the world. So for example, look at Africa. North Africa is majorly the dry region. You can see that the belt here between sub-Saharan and Northern Africa has a distinct high level of vulnerability to desertification. And you have these parts of, and this is Russia. You can see that. You can see parts of even America, parts of Southern America, parts of the Oceania continent, so parts of New Zealand, Australia. So even Madagascar has some section that is threatened by desertification. And this is a unique and major problem in Africa because 65% of the land in Africa is dry land, as you can see from this map here. So 65%, look at this place, this region, they're all dry lands in Africa. And then 1/3 of this area are already desert areas, so hyper-arid. Aridity means very dry area, and very few of these areas are inhabited. Those areas that have oases in them, where they have water bodies like maybe that's where you find habitation. And then 2/3 of the remaining dry land are home to over 400 million Africans. And then the soil, like I think I've mentioned previously in one of our classes, that the soil in Africa is low infertility because of the bedrock. It's from the what they call the Precambrian basement complex rock, which is believed to be low in its nutrients in its fertility. You have a lot of granite and gneiss rock, weathered rock in most parts of the dry lands in Africa. And then the soil is also, there's very low clay content in the soil. And so this makes it easy to move. But with the slightest of disturbance from wind, for example, the soil moves fast. And you can see here again, this is another depiction of the areas that are also prone, particularly the shrublands. As you can see, the shrublands, they're all prone to desertification in Africa. About 200 million tons of crops are lost annually in Africa on about over 100 million hectares of cropland, partly because of erosion. And then most of the planting, the agricultural practices in Africa are poverty related because we still practice subsistence farming, continuous cultivation of land, overgrazing. We don't have irrigation systems. We don't have water conservation structures in place. Where in the savanna regions of Africa, you have a lot of bushfires that destroy large portions of the ecosystem, of the savanna ecosystem. So, and then, like I said earlier, the geology is the Precambrian age, or over 600 million. For those who believe in that the world is over millions of years and all that, you have human activities affected by the soil conditions in the different parts of the world. There's a lot of migration, there's a lot of drought. All these things threaten the land and cause a lot of degradation, accelerate degradation, and predispose the fragile arid and semi-arid lands to desertification. Also, you have over 319 million hectares being vulnerable to sand movement, what we call the formation of sand dunes in many parts of Africa. And it is estimated that about 20,000 hectares is lost annually due to desertification, the inward movement of the desert inland. In Africa, for example, in Ethiopia, 70%, and then in Kenya, 80% of their land are prone to desertification, with many Africans moving to Europe, moving away from North Africa or from Sub-Saharan into Africa because of the threat of desertification. It was estimated that by 2020, which was last year, about 50 million people were going to move from desertified areas, from areas that have been degraded due to desertification, into Europe and North Africa. And so this desertification is simply caused by the movement of sand and the formation of sand dunes. And a sand dune is a mound of sand formed by wind, either on the beach, so you can have beach deserts, or in the desert area, for example, the Sahara Desert. And this is as a result of wind blowing sand. And as the intensity and velocity increases, you have grains of sand accumulating in heaps around different parts of the desert region. And so you have the slip side, you have the wind direction side, what we call the windward side, and the leeward side. And so the sand moves and then settles on the slip face. You can also have these dunes underwater. So underwater, what we call underwater dunes, in subaqueous dunes, in oceans, in rivers, and in canals. And the shapes of dunes vary based on geographical features. Well, we can classify them into 5 major types: crescentic, linear, star, dome, and parabolic dunes. So the crescent, just as the crescent of the moon is the shape of the crescent of the moon, is, you have wind from one direction flowing, and then there's an arc on the other side, like a C, let's say C. And crescentic dunes they are fast-moving dunes, and they are very common. You have linear dunes that are formed, they are like straight or nearly straight lines. They are sometimes shaped like snakes, wiggling like snakes, as you can see. And they develop where wind pressure is normally equal on both sides. So in this case, you don't really have a windward side or a leeward side. So you have wind flowing from various directions. And then this causes this interesting geological features that look like straight lines, or they are wiggling snakes. Then you have star dunes that they look like stars when you look at them from using the aerial view. These are very common in the Sahara Desert. These are also because these star dunes are formed, they have pointed ridges and slip face on at least 3 different sides because of wind flowing from different directions. You have the dome dunes, which are very rare, but you can have them. They look like domes, and they are circular, and they don't have slip faces. We also have parabolic dunes, which are similar to crescentic dunes. The shapes are usually rough, but the slip side face of the parabolic dune is it's inwards on the inward side. So you can also call these parabolic dunes blowouts, because wind blows out the center of the dune, leaving just a rim on the outside. And just briefly to mention here that as difficult as life is in the desert, there are still some plants and animals that can survive there. Particularly in beach deserts, you have what we call beach grasses. You have sandfish, which is a reptile. It's not actually a fish, but it's a reptile that can retract its legs and swim through smooth sand. You have larger animals too that you can find here. These animals have adapted, like the Asiatic cheetah. These animals have been able to adapt to the difficult conditions in deserts, and they are able to survive there. So sand dunes are very interesting because they are not formed by erosion due to water, but erosion due to sand scoring. So the abrasive surface of weathered rock, when wind hits them, it breaks them gradually, and then sand is released. And the mode and rate of movement of these dunes are dependent on the size or the type of the dune, the velocity of the wind, the sand grains, the properties and the size of the sand grains, the humidity of the dune, and also the relative density of the layers in discussed. So one of the ways of trying to control desertification is what we call sand dune stabilization. And if you go to the LMS, you'll see I'll put some materials there for you where these things are described in detail, and they will give you a deep understanding. And why are we doing this? Why are we discussing this topic? Because a lot of you in the future will become international professionals. You would work in international agencies, and you may be faced with managing crises that are related to desertification. Or some of you may find yourself in the north where desertification has become a problem. So it suffices then, and it is essential in forest restoration and rehabilitation, that we also talk about what happens in areas that are prone or susceptible to desertification. I hope you are still with me. Hello, are you still there?
Yes, sir.
Yes,
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 sir.
sir.
Yes, sir.
All right, let's continue. So sound stabilization simply is the effort aimed at controlling sound movement, either through chemical, mechanical, or biological approaches. Today, we are just going to quickly talk about mechanical and biological. You would also find more information about the chemical methods in the material that I've sent to you. So the mechanical dune stabilization is one of what we call the primary fixation. There's something we call sand dune fixation. And the primary thing to do sometimes is just to go mechanical. And it's the initial stage of trying to combat sand encroachment, where you erect fences that are about 1.1 to 1.5 meters high to intercept the wind and create what we call artificial dunes. And the fence would also slow the flow of air, causing the air to release the sand at its load at this point when it hits the fence. And there are two types of artificial dunes that you can create with these fences, depending on the position of the fence and in relation to the direction of the prevailing wind. One is called the stop or check dunes. And there's a particular PDF file that I think I've uploaded. I'll check if I didn't upload it. I'll put it there too. That has pictures that will sort of show you some of these interesting techniques. Let me just quickly see if I can run there and show you something. I hope you can still see my screen. Can you still see my screen, ladies and gentlemen?
Yes, sir. Yes, sir. Yes, sir.
Oh, all right. Let's see. Okay, let me check if I put that material in the let me check. Is it this one? While that is downloading, so let me go and check my files. Right. So, just a minute. Let's see if, okay, I think it should be the same. Oh, yes, this is what I was looking for. So you can see some of the methods that are used for stabilization. So this is an example: straw, checkerboard, and bales. Look at that. This is another one, checkered. You can see these are straw from plants that are put in there to control, made sort of like a fence. So when you look through, you see a lot of pictures of different methods and fence. This is another one. They use polystyrene here. They use, I think, plastic here. Can you see the picture? Look at areas that have been restored.
I can't see it though.
No, sir, my own screen is not changing yet.
You can see the pictures.
Yes, sir.
All right, let me reshare. Can you see the pictures now?
Yes, sir. We can see it now.
All right. So
Yes,
these
sir,
are
we can see, sir.
different techniques, straw that have been used to make checkered boards. And you know what this will do? This will hold the sand and prevent sand movement. Boardwalk across stabilized areas. So they are planted here, fence, checkered boards, and all that. You see, you can look at the pictures in the material data. You can download the materials from the page. Can you see the slides? Can you see the slides?
Can you see the slides?
All right.
Yes,
So,
sir. We're seeing it now.
all right. So this is the stop or check dune.
Yes, sir.
So you can see that the fence, which would have maybe straw, or it could be plastic, it could be wooden fence with straw in it, is what is at 90 degrees to the prevailing wind. And this is the area that I'm trying to protect. While the other one is at an angle of 120 to 140 degrees. So it's called the deflection or diversion dune. These are mechanical ways of trying to control them. And these are some of the plants that they get twigs and branches for that they use for making the fences. You have prosopis. We have different prosopis species in Nigeria, in the north. Balanitis actica is a common species in Yobe, in some of the areas that approach desertification in the north. Palm fronds, and this sort of explains how you set up the fence. For example, if a fence is to work effectively, it must have a 30 to 40% permeability to the wind, so that it curbs wind speed and causes a buildup of sand without causing wind turbulence in the lee. So the leeward side is the other side, and be no more than 2.2 meters high, in as much as 95% of the wind-borne sand is found in the first 30 centimeter above the ground. So, and then another mechanical method is the mulch or protective screen, which is covering the dune uniformly. Some of the things you saw, those checkered with straw, branches, stalks, plastic fume. Sometimes in some places where they have a lot of crude oil, they can even use crude oil, asphalt, heavy oil to hold the sand, keep it from moving. This is not very clear. But this they use polystyrene, which is a plastic like nylon, to form grids to hold down the so it's like a mulch. I hope you know what a mulch is. Another method that's mechanical is the aerodynamic method. Sometimes using stone, and what they do is they use this to either break the wind of the speed, the speed of the wind, or increase the wind speed. And so there's a way they would arrange the stones, like some of the things you saw in the video that I showed earlier. And then you have biological fixation, which is using biological method, which is basically using plants to try and hold the stone. So it is aimed at establishing places for plants to be able to grow despite the harsh condition there. Bare sand dunes have the special feature of conserving parts of their water for long periods of time because they have high reflective light reflection coefficient. So they reflect most of the light, so they don't absorb the heat. And then low heat conduction rate. So they are able to hold on to the water in lower parts of the system. So you can plant deep-rooted plants there, which will grow and then help you restore the place. But some of the things you need to consider is the choice of species. You need species that can survive, both woody and grass species. So that you need to consider the climate and the ecological conditions and if they are suitable for the plants to survive. Look at species that have the capacity to grow in nutrient-poor environments, species that have taproot systems, and they can tolerate drought or use residual soil moisture. They are resistant to abrasive action. Abrasive action is when the stones, the hot sand, when it hits the surface of the leaves, it can cut them. It can tear the leaves. But these are plants that have very strong tender leaves that can survive under such conditions. And then they have the capacity to help improve the soil. Either they are nitrogen fixing or they enrich the soil. I have a few species here that are commonly used. Some of them you can find them in Nigeria, like casuarina. You can find this in Nigeria. Some of the tamarinds too. So those are allophytic plants that can survive under very harsh weather conditions. You also have woody species like the prosopis species, Balatinitis atypica, and the Euphorbia, and the acacia species especially. So in the planting techniques that you want to adopt for such environments, you need to plant at the time when you know that rain would fall, where, particularly during the rainy season, where the ground is sufficiently moist for the plants to be able to establish their roots and grow. And then you also need to vary the density depending on the type of species and the type of area where you are working. You know, in such areas, density, you need to be sparse. You don't need to be densely, the plants to be densely populated. So some places you may use 5 meter by 5 meter spacing. Some places it could be up to 10 meters by 10 meter, depending on the dune and your accessibility to it and ability to be able to suppress the wind erosion. The rule mostly adopted recommends that you plant 1 woody seedling per hectare per millimeter of effective rain. So if you get 200 millimeters of rainfall in a particular area that is prone to desertification, you can plant 200 woody seedlings per hectare of that area. So you can calculate the espacement from that. And to calculate the espacement for this, you have to, you know that, sorry, let me just see if I can quickly do that here. Can you see my pen? You know that an hectare is 100 meters by 100 meters. I hope you all know that. And then you want to plant 200 species, 200 seedlings. So it's equal to, you want to raise 200 seedlings because you get 200 millimeter rainfall per annum in that area. So to get the espacement, and to get the espacement would be, let's say, X. X times X. Let's just use this one. So if you make X the subset of the formula, you then have 10,000. That's the 10,000 meters is the size of the area of 1 hectare divided by 200. So that's 0. So this is 50. So it is supposed to be 50 meters squared. That should be the espacement. So if you find, so it means you can use maybe 10 meters by 5. So 10 by 5. You can use 10 by 5 as your espacement in that 1 hectare, because 10 times 5 is what? Is 50 meters squared. That means in between a line, you can have trees 50 by 50, 5 meters by 5 meters apart. And then because of the dunes, you can then have the lines to be what? 10 meters apart. So let's say this is a line. So in between them, it will be 5 meters. And then maybe your sand dune is here. Then your next will be here like this, another set of trees, 5 meters apart. And then the distance from here to here will be 10 meters. Something like that. I'm just trying to see how I can explain it to you. So you prepare the land. Seedlings can be placed parallel to the fences to form a live fence that may, in a short time, replace the dry plant matter used for mechanical stabilization. So after stabilization, you can then plant such an arrangement that once the fiber used in the mechanical stabilization, once they wither or they rot, the planted seedlings can take over. And like I said, rainfall is very important. So you plant after you have received sufficient rainfall in such areas. And then this sort of explains some of the characteristics you need to think about when you are planting, how you need to plant. When you get your seedlings, in polypots, for example, you slit it open, and then you allow water to be able to drain in. Then you place them in the planting holes. These are additional information about the planting. Or you could use direct sowing. If you like what you saw in the video, you can broadcast your seeds. You can soak your seeds in what do you call it, in rodenticides or insecticides, so that insects will not feed on them, and then you just broadcast them and you allow them to grow. Once there's enough moisture, they will germinate and grow. But usually you have a lot of high mortality when you use direct sowing. And then I have this here just to show you that currently there's a project that is going on. You can Google and read about it. It's called the Great Green World Project, which is an Afrocentric project. It's a project driven by the African Union. You know, Africa we have the Sahara Desert that cuts across the entire, like I showed you earlier. And most of the countries that form a border with Sahara are threatened by desertification. In Nigeria, we have 11 frontline states, as you can see, that are affected by, that are susceptible to desertification. So what has happened is that the Great Green World Project aims to create a green barrier, plant a green vegetation across the entire Sahara Desert, which will form a strip of 15 kilometers wide. So the width will be 15 kilometers, and the length across the entire African region will be about 7,000 kilometers. And to date in Nigeria, there's a record that they have planted over 7 million seedlings on 5 million hectares of land today, created jobs, planted multi-purpose species, and this have become shelter beds in 11 states, in Sokoto, Yobe. If not for the problem of Boko Haram now, that project should have moved beyond where it is now. So thank you for listening. Are you still there? Do you actually have my audience?
Yes, sir.
All right.
Yes, sir.
So I'll take questions from you now. Why do you think it's important for you as a forest scientist to have information about desertification and sand dune fixation? Adam Olarewaju, can you answer that?
As a forestry student, we really need to have this knowledge because it will really play, like it goes pari passu with our field of studies, because if we want to embark on a particular project, maybe a restoration project, probably any one of us goes to that line of studies and doesn't take cognizance, like, or doesn't take consideration of maybe the effect of the sand dunes, maybe, and like maybe after a project, you didn't take consideration of dunes formation around your project's site. It might really hinder the success of the project to be embarked on, sir.
Okay, you have tried. But for example, I hope that some of you know that you may end up going to the north for maybe your service here. And the north today is struggling with this problem of desertification. You may be called upon to lead a project to try and combat desertification. So it's very important that you know those things. Apart from that, you are global citizens. You can contribute to knowledge. You can even set up and start projects that will help maybe try to combat desertification in Nigeria and even in Africa. I just told you about the Great Green World Project. You can tap into it and look at the opportunities that are available to you and how you can also contribute to the success of that project. Does that make sense? Does that make sense?
Yes, sir. Yes, sir.
All right.
Yes, sir.
Do you have any questions for me? Questions?
Sir. Good afternoon, sir.
Yeah, good afternoon, Azanat. How are you?
Fine, sir. Sir, I find this ecologically important because I was wondering why we need to fix them, because they said there are some animals that live there. Instead of fixing sand dunes, why don't we fix our own tropical or other ecosystem that we destroyed?
So you said, why are we why? You said, why
Are
are
we
we?
fixing sand dunes?
Okay. Have you heard? There's a word called there's a word known as the shifting ecosystem. It is believed that it has been predicted that if you look at Nigeria, Nigeria has, how many ecological zones do we have in Nigeria? Let me see if I can share the slides and just show you something from there. You know, we have rainforests, we have savanna, we have, let's see. Now, you know, in Nigeria, this is the map of, can you see the slides? I'm sharing the slide, can you see it?
Yes,
No,
sir.
sir, we can't.
Okay,
No,
sorry.
I can't see it, sir.
All right, just a minute. Just a minute. Can you see the screen?
Yes, sir.
All right. Now, in Nigeria, we have, from natural ecosystem, we have different ecological zones. In this region, we have the mangrove ecosystem, we have the rainforest ecosystem, we have the derived savanna, isn't it? We have the Guinea savanna, Sudan savanna, and Sahel savanna. The Sahel savanna is what borders the Sahara Desert, isn't it? Now, it is believed that if the predictions for climate change are right, there will be a shift such that what is now known as the Sahel savanna will become what? Will become desert. And then what is now known as Sudan savanna will become Sahel, which means that the desert will continue to move inwards. And then before you know what's happening, even the rainforest zone will be threatened. And remember that we have a mix of derived savanna and rainforest in most parts of southern Nigeria. In your state, for example, when you travel to most parts of Okeogun, that region is savanna, even though most of it is derived savanna. But what could happen is, as if desertification, desert encroachment continues, that derived savanna will become a Guinea savanna. And that's a problem because it would lead to loss of species, loss of biodiversity, loss of ecosystem. So there's a problem there. That's why it's important that for us to be aware of this thing and for us to work and be able to intervene when we need to intervene as professionals. I hope that answered your question, has or not?
Yes, sir. Thank you, sir.
Okay. Any other question? Questions, please. Okay, so I'm going to post an assignment on the LMS page, and I want you to all work on the assignments. The assignment is, I'll type it on the LMS page anyway, for those who are not here now. I want you to go and to do an essay on Nigeria's involvement in the Great Green Wall project. Did you get that? Write an essay describing Nigeria's involvement in the Great Green Wall project. Is that clear?
Yes, sir.
Yes, sir.
Okay, let me just type it into the. Is the class rep around? Is the class rep around?
No, sir, he's having an issue with his phone, sir, so he couldn't get one.
I'm trying to post the. Okay. So can I quickly set up the attendance and use this for attendance? So you have 1 week. I want to set up the assignment now. So that's there now. You can find it on the sites too. Okay. So is Kemi? Yeah, Kemi, can you take attendance, please?
Sir.
Please take attendance. Please
All right,
put on your cameras. Let's do a what do you call it? Let's take a screenshot. I'm waiting. Please, I need to go off in another 5 minutes, so let's quickly do that. Okay. 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 We're waiting for Deborah, Omotara, and Salma. Lawal Azizat. Are they not there? It means they are not there. Okay. All right. Smile for the camera. Okay. Thank you, everybody. So we'll have maybe one more class, 1 or 2 more classes, and then we'll be done. 1 or 2 more classes, and then we'll be done. So I want to wish you all a wonderful afternoon. Thank you for coming, and I'll see you some other time. Bye-bye.
Thank you, sir. Thank you, sir.